Hi, so my name is Cameron Setter. I'm the head of maths at St Julian's School, and I've been asked just to do a quick presentation on my maths department's journey over the past 2 years. We started by focusing on what we're going to teach. So we had a session as a department where we thought about the base of our pyramid. What topics form the base and form the foundations that we're going to build on top of? So you can see here, this was from a CPD session where we had lots of little post-it notes. We did it on computers, and we just arranged them as to what do you think would be at the bottom of our pyramid, what comes slightly further up, and then obviously what's at the very top. So we sort of decided there's lots of numbery based topics at the bottom of our pyramid. At the very top, you've obviously got things like your data representation, simultaneous equations, 3D shapes, etc. So this is our current curriculum. This isn't a finished model. This is something we are tweaking, and even for next year, it's slightly different again. You can see that year 7, we've started by working on the fundamentals, lots of number work, but then that leads into year 8, where we start to go into a bit more data and algebra. Year 9 is where we start connecting that to then some geometry, and obviously year 10 and year 11, we're developing and applying that ready for GCSE exams. We felt that this was the right move for us as a school, and even though it seems like we're doing very number heavy in year 7, very algebra heavy in year 8, actually the thread of multiplication, we can see in year 7 we look at multiplying and dividing. Year 8 we've got things like expanding and factorizing. Year 9 you've got your proportional reasoning. Year 10 you've still got rates of change. So that thread of multiplication kind of covers all the way through. That's the same with a number of different areas of our curriculum. Once we established what we're going to teach, we then focused on how we're going to teach. And for me, it comes back to the 5 proficiencies. So some of us had a bit of an idea, especially things like fluency, but we wanted to embed this a little bit further. We sort of picked out 1 or 2 little areas we thought we could focus on, and we kind of went down the route of either representations, so using our bar models and number lines to represent the maths, or looking at something called variation theory. And for us, because we had a number of teachers who already had an idea about representations, we wanted to go down the variation theory route. So variation theory is this idea that we're going to keep some things the same, but vary some of those other features so that students can recognize those underlying structures and pick out those key essential features so that hopefully they develop that better understanding. What we don't want students to have is that limited view of topics. We wanted to really vary things so they could apply their knowledge. I won't just read this slide, I'd really recommend pausing. I think it really resonates with what we were trying to do. For us, it came back to this quote, that a misconception is very often a limited experience. So by just showing students all of the same style of questions, they're going to develop misconceptions. If we can show them lots of different variations of questions and variations of things they'll see, they'll develop a better understanding, be able to apply their knowledge in different scenarios. So as an example, here I've got some right angle triangles. You can see that if I was teaching Pythagoras' theorem, I could show lots of these triangles and show them that the colour doesn't matter, the orientation doesn't matter, the size doesn't matter, they're all still right angle triangles. And they're all different things that we would like to show students when we're teaching Pythagoras' theorem so that they can apply it no matter what the question throws at them. We also have run CPD sessions where we've looked at different parts of our curriculum. So for example, year 7, we look at median and the midpoint of 2 numbers, and we discussed what's the standard thing to be asked, what's a perhaps non-standard thing to be asked, what are those non-examples, and in general, what are we trying to get students to understand. So for example, the median, it might be things like, in general, we want them to understand that we're going to put our numbers in order, we're trying to find that middle value, whereas a standard question might be where actually the middle number is really, really obvious. A non-standard might be where we're finding the median of negative numbers or of fractions, of decimals. It might even be where we've got 2 middle numbers that are both the same. So they're all the things we looked at. And again, non-examples where we often find students confuse the median with mode, mean, etc. There is one warning though that I do want to mention. Variation is not the same as variety. This is a really typical example of an exercise that you might see in textbooks or online where students are trying to solve equations. And while it looks like there's different letters involved, there's different numbers, some are adding, some are taking away, there's negatives, it seems like there's lots going on. Actually, if students can procedurally follow the steps, they could probably answer everything there. But I would argue the variation isn't there. There's only 3 questions that truly make students think. And I've highlighted them there because they've slightly changed the way they look. Now what we want is where that variation is embedded and it's throughout, so that if students have a deeper understanding, they know exactly which parts to do first, they can follow the steps and they know why. And that's the bigger thing for us. Here is an example of the sorts of resources that we are trying to promote a little bit more. So you've got a completion table where we're going forwards to work out the mean, going backwards when we're obviously given the mean to find missing numbers. There is also links between questions. So for example, the first one and the second one, you can see I've just added 1 to all the values. It gives students a nice opportunity to discuss what's going on and obviously develop that deeper understanding as to how we're calculating the mean. Here is another example of a resource that shows lots of variation. You can see some questions are using the multiplication sign, some questions are using the dots. You've got squareds in there, you've got going forwards to find your answer, you've got going backwards. There's links between the questions, there's some nice things to talk about. So F, for example, you've got a whole time, or 1 times by an eighth. Loads of different things going on there that are going to make students think about what they're doing rather than just following the steps. So now that we are teaching really effectively, we're hopefully showing lots of variation, we're teaching the right things, it's then about how we know that students are learning. And we're really heavy in my department on using mini whiteboards. We use them a lot within lessons. It allows us to be really responsive, pick up on those misconceptions, and obviously check whole class understanding. So something we really push and promote. We then also use something called a hinge test. So these are little tests partway through a unit, not at the end of a unit, because we feel that there's no point moving on to the next thing if they can't understand the first parts. These hinge tests are split into 3 sections. So you've got the understand, the do, and the apply. Where the understand, you can see there's some representations. The do is, can they just do it? Can they do Pythagoras? And then the apply for us, it could be context, it could be linking obviously triangles together in this case here. It's just whatever we deem applying it to be. Following this hinge test, we're actually quite strict and quite rigid with how we feed back. So we've got a whole process then feeding back from our hinge tests. And finally then we have our bigger summative assessments. These happen once each term, so Christmas, Easter, and then end of the year. And what we have with these is a core section that everyone in that year group will be assessed on. So it's the core knowledge we think actually they need to be able to nail down and know. If you are then a top set student, there's also an additional couple of questions on top of the core, just to stretch us a little bit further. Again, if you're at the bottom end of bottom sets, there is another additional couple of questions that just build you up, build your confidence up a little bit, warm you up before the core section. So what's next for us? Well, we've started to move to all of our meetings, or as many meetings as possible, being purely about how we teach topics. So this is an example of a meeting that we looked at directed numbers and how we're teaching that, going from what we want students to know through to what we currently do, and then looking at loads of other resources and other representations that we could be using. This then informs our teaching going forwards. The next part that we're going to look at is using representations a lot more. So as I mentioned earlier, quite a few teachers are already aware about representations, but perhaps aren't using them as much as they possibly could, and it isn't embedded yet within all of our teaching. So we want to promote that a little bit more, doing things like bar modeling and using the number line a lot more for lots of different topics to help students develop that deeper conceptual understanding. And then the final thing that we're really using are department textbooks. Now we've used a lot of resources from Oat Maths. They're an academy in England, and they've incorporated things like you can see on the screen, loads of different variation that is embedded. So we want to give all of our teachers textbooks with this throughout that is linked to our scheme of learning, so that teachers don't have to worry about what students are going to do. They know that this is the task students are going to be doing, and they can spend all their time planning on the best explanation, the best way for students to understand how to multiply fractions or whatever it is they're doing. So this is where we're moving forwards, again, trying to reduce the workload, but improve our actual teaching in the lesson.